Hello chemists, and welcome to the latest video in the Chemical Earth series. In this one we're going to look very briefly at gravimetric analysis. Gravimetric analysis is a technique that we used in chemistry that is based on determining the composition of a particular compound or a mixture on the basis of its weight. So most of the time when we're looking at gravimetric analysis, what we're trying to do is to determine a method which is going to allow us to determine the percentage composition of any substance, compound or mixture that's present using procedures that are related to the relative weights of the different components in the mixture or the compound. We will look at how we apply gravimetric analysis to compounds at a later point. Most of what we've looked at so far, though, has related gravimetric analysis to the components of a mixture. Gravimetric analysis is a very useful technique to chemists and other scientists as well, particularly for determining things such as the percentage of a metal in an ore body. This can be very important economically to determine whether or not it is actually profitable to mine a particular ore. If the composition of the metal that's going to be extracted from that ore is very high, then that may be far more economic than if the value of that metal falls too low. Likewise, we can carry out gravimetric analysis on soils to determine the composition, particularly if there are certain trace elements that affect plant growth. And different plants require different sets of conditions, different trace elements, fertilizers, nitrogen, phosphates, and so on. And so gravimetric analysis helps us to determine for a particular soil sample exactly what the composition is and whether or not we need to add things like fertilizer or lime and change the composition. In order to carry out gravimetric analysis, we need to determine first of all the separation method that we're going to use. If we're looking at mixtures, then usually it will be a physical separation method, but if we're looking at compounds, then it may involve some sort of a chemical reaction. So if, for example, we were to look at seawater as an example of a mixture, the seawater would contain salt and water, and we'd want to separate those. So the first step would be to weigh the sample. So when we collect our sample of seawater, we need to weigh the entire sample. The second step will involve the removal of the water through evaporation and recovery of a dried salt residue. So we will have the salt left in our evaporating basin, for example. The third step will be to weigh just that salt component of the mixture. And then by comparing 3/1, we will end up with a fraction which we can convert through multiplication by 100 into a percentage composition for the salt in the salt water. So here's a question. A 12-gram sample of an ore was found to contain 3.6 grams of the metal aluminium. What does this represent as a percentage? And if the ore needed to contain at least 45% aluminium to be viable, economically, would it be sensible to mine this ore? Well, in the first case, we have 3.6 divided by 12 multiplied by 100. And that gives us an answer of 30%. Now, because 30% is less than 45%, then the amount of aluminium that we're going to extract from this particular ore will not make it viable. Not viable. Thank you for watching.